You are again welcome to my another class. Today I will teach you the successive derivative or the higher order derivative. Look at here. Let y is equal to f of x be a function of single variable x. Then if f of x is differentiable, that means if derivative of f of x exists, then the derivative of y with respect to x is written as dy by dx or d by dx of f of x, which is the first derivative, and it has different notations. Like this dy by dx is written as y dash or y1, and similarly derivative for f of x is also written as f dash x. First order derivative. If we want to look at here, suppose y is sin x, then dy by dx is derivative of sin x is cos x. Dear viewers, we are generally differentiating a function, but sin x is a function and its derivative is also a function. So if cos x is a function, then it can be differentiated. That means this dy by dx can also be differentiated. That means derivative of a function can again be differentiated. So now successive derivative. Successive means one after one. So how can differentiate the derivative of a function? That means now we find derivative of a function. So if y is a function, then dy by dx is also a function. We want to find derivative of a derivative. That means we want to find derivative of d by dx of dy by dx. So we will differentiate this. That means derivative of f of x with respect to x. Look at here, this has the notation d square y by dx square. That means second derivative of y with respect to x, and this is d square of f of x with respect to x. And this has also symbols like this. This can be written as y double dash or y2, and this is f double dash x. Again, if d square y by dx square is a function, then we can take the derivative of this. That means again we can take derivative of d square y by dx square, and this is dqy by dxq. So this is first order derivative, this is second order derivative, and this is third order derivative. Continuing in this way, we can find the nth order derivative. That means dny by dxn, which is also written as yn, and this is the derivative of dyn minus 1 by dxn minus 1. Look at second order is derivative of first order, third order derivative is derivative of second order. Continuing in this way, fourth order derivative is derivative of third order, fifth order derivative is derivative of fourth order. Similarly, dny by dxn is the nth order derivative is the derivative of n minus 1th order derivative. So we write this as first order derivative and this as second order derivative, and this is third order derivative, and this is nth order derivative. So these we get one after one. That's why all these known as successive derivative, one after one. And after first order, the rest are the higher order derivative. Higher order derivative means after first order derivative. Now important notation. Let y is equal to f of x be a function. So the first derivative is represented by these symbols dy by dx or y1 or y dash or f dash of x or dy, where y is equal to f of x. The first order derivative of y is equal to f of x is of this form, and the second order derivative is dy by dx. Derivative of dy by dx is d square by dx square or y2 or y double dash or f double dash x or d square y, where this d where this d is d by dx, the differential operator. This is the differential operator. And similarly, the third order derivative is dqy by dx, qy 3y triple dash f triple dash x, or dqy. And the nth order derivative in continuing this order, continuing in this way, the nth order derivative is dny by dxn, y3, sorry, this is yn or yn or fnx or dny. So all these are the derivative at x. But if we want to find the derivative of a function, value of derivative at a point, particular point a, then put x is equal to a. So this is the nth derivative at x is equal to a. Yn means this is derivative at x, and yna means derivative at a. So fna means the nth derivative function at x is equal to a. This is the symbol of nth derivative at a particular point x is equal to a. The important thing is the second order derivative of parametric functions. Many times the students facing lots of problem in solving this type of problems. Really, how to find the second order derivative of parametric function. Suppose x is equal to f of t and y is equal to g of t is the parametric function, where t is the parameter. Here, how can we find the second order derivative? That means d square y by dx square. Look at here, d square y by dx square is actually d by dx of dy by dx. So if here t can, in my first class I have already said, if t can be eliminated, then this y can be function of x. Then this can be implicit function, but naturally always not possible. So here you can find d by dx of, look at here, y is function of t, so find dy by dt, and x is also function of t, find dx by dt. Look at here, we divided dt and dt. We divided dt on a numerator and a denominator. But here what happens, look at here dear students, dy by dt, y is a function of t means this is a function of t, x is a function of t means this is also function of t. That means this portion inside the bracket is function of t. So how can we find the derivative of this with respect to x? Now dear students, derivative of this portion dy by dt by dx by dt, as this is a function of t, then differentiate this with respect to t into dt by dx. Look at here, we have d by dx, I multiply dt divided dt. So find the derivative of this with respect to t into dt by dx. So how can we find dt by dx? We have x. So if x is function of t, we can find dx by dt. So here find dx by dt. If we can find here dx by dt, then multiply here dt by dx. Dx by dt is given, so 1 by dx by dt is dt by dx. So this is the process to find the second order derivative of parametric function. One important question, if y is equal to tan inverse x, then show that 1 plus x square into y2 plus 2xy1 is equal to 0. Now the solution is given y is equal to tan inverse x. Now differentiating both sides with respect to x, we get dy by dx is equal to derivative of tan inverse x, which is 1 by 1 plus x square. Dear students, we have this dy by dx is y1 as the notation, y1 into 1 plus x square, इसको multiply कर दिया is equal to 1. So this is equation 1 and this is equation 2. Now again differentiating both sides with respect to x, we find, look at here, derivative of y1 into 1 plus x square is equal to derivative of 1, which implies, here is the product formula, derivative of y1 is y2, derivative first into second plus first into derivative of second, derivative of 1 is 0 and x square is 2x. is equal to 1, derivative of 1 is 0. This is, we find here 1 plus x square into y2 plus 2xy1 is equal to 0. So proof. Given y is equal to e to the power 2x into sin x, find y2. Now y1 is derivative of y is equal to derivative of y is e to the power 2x into sin x. Apply product formula. Derivative of e to the power 2x is e2 into e to the power 2x. Derivative first into second plus first e to the power 2x into derivative sin x is cos x. So this is y1. Now y2 is derivative of y1. This is a derivative of 2 into e to the power 2x into sin x plus e to the power 2x into cos x. This is equal to, here is derivative first, 2 into e to the power 2x, derivative 2 into e to the power 2x. So this is 4 into e to the power 2x into sin x, derivative first into second plus first into derivative second. And here is derivative first is 2 into e to the power 2x into second plus first into derivative cos x is minus sin x. And this is equal to 4 into e to the power 2x into sin x plus 2 into e to the power 2x cos x. Here is 2 into e to the power 2x cos x, 4 into e to the power 2x cos x minus e to the power 2x into sin x. So you can take common e to the power 2x and to find the answer. Another important question, if y is equal to e to the power m cos inverse x, then show that 1 minus x square whole into y2 minus x into y1 is equal to m square y. Now the solution is, here given y is equal to e to the power m cos inverse x. Differentiating both sides with respect to x, we get dy by dx is equal to derivative of e to the power m cos inverse x, which implies dy by dx is y1, and this is equal to derivative of e to the power m cos inverse. Here we apply e to the power x, that means e to the power m cos inverse x into derivative of m cos inverse x. This is equal to, and e to the power m cos inverse x is equal to y. So this is equal to y into derivative of m cos inverse x, means m is constant and the derivative of cos inverse x is minus 1 by root over of 1 minus x square, which implies, look at here, y1 is equal to this much, multiply this, we get 1 minus x square root over into y1. here डिवाइड हुआ था, मल्टीप्लाई कर दिए, इज इक्वल टू इधर हो गया minus m into y. Now squaring both sides, we get 1 minus x square into y1 square is equal to m square y square. Again differentiating both sides, with respect to x, we find derivative of this. So this is derivative of 1 minus x square into y1 square is equal to derivative of m square y square, and which implies derivative of y1 square is 2y1 into y2 into derivative of y1 square into 1 minus x square plus derivative of this is minus 2x into y1 square is equal to derivative of m square y square. M square is a constant and derivative of y square is 2y into derivative of y. Derivative of y is y1, which implies this is, so now this is 2y1 y2 into 1 minus x square minus 2x y1 square is equal to 2m square y1. So the common term is 2y1. So cancelling the term 2y1, we find here 1 minus x square into y2 minus 2y1 cancel हो गया, x into y1 is equal to m square y, and is proved. Another important question, but this is in parametric form. X is equal to sin t, y is equal to sin 2t. Then show that 1 minus x square into y2 minus x y1 plus 4y is equal to 0. So solution is given x is equal to sin t. Given x is equal to sin t and y is equal to sin 2t. Now here t is equal to sin inverse x. If x is equal to sin t, then t is equal to sin inverse x. Put here y is equal to sin 2, t is equal to sin inverse x. So this become implicit function. In order to find this, we have to differentiate twice. So differentiating both sides with respect to x, we get derivative of y with respect to x is equal to derivative of sin 2 sin inverse x. Derivative of y is y1 is equal to, this is sin theta, and derivative of sin theta is cos theta, cos 2 sin inverse x into, we have to multiply derivative of 2 sin inverse x, which is equal to cos 2 sin inverse x into derivative of 2 sin inverse x is 2 by root over of 1 minus x square, and multiply this here, we get 1 root over of 1 minus x square into y1 is equal to, this is 2 cos 2 sin inverse x. Now squaring both sides, we get 1 minus x square into y1 square is equal to 4 cos square 2 sin inverse x, and this is 4, this is cos square theta, and I can write it as 1 minus sin square theta, means sin square theta is 2 sin inverse x, which is equal to, look at here, which is equal to 4 into 1 minus, dear students, sin 2 sin inverse x. Sin 2 sin inverse x is y, and this is sin square 2 sin inverse x, means this is your y square. That means we find 4 minus 4y square. We have 1 minus x square into y1 square is equal to 4 minus 4y square, and again differentiating both sides with respect to x, we get differentiating derivative of this x square is 2x, y1 square is 2y1 into derivative of y1 is y2, derivative of this into 1 minus x square plus y1 square into derivative of 1 minus x square is minus 2x. Here is product formula, derivative of u into v plus derivative of v into u is equal to derivative of this, derivative of 4 is 0 minus derivative of 4, and derivative of y square is 2y into derivative of y is y1, which implies we find this is 2y1 into y2 into 1 minus x square, this is minus 2x y1 square, minus is plus हो गया, is 8y y1 is equal to 0. So cancelling the term 2y1, because 2y1 is present in every term, so taking common and dividing 2y1 on both sides. If we divide 2y1 on each term, then we find this is 1 minus x square into y2 minus 2y1 divided करने से xy1 plus here 2y1 divided करने से 4y is equal to 0. Hence proved. One important question, if 2y is equal to x whole into 1 plus dy by dx, then show that y2 is constant. Now the solution is given 2y is equal to x whole into 1 plus this is y1, dy by dx is y1. Differentiating both sides. Differentiating both sides with respect to x, we get 2 into derivative of y is y1. Here is x, derivative of x is 1, product formula, derivative of x is 1, derivative first into second is 1 plus y1 plus x into derivative of this, derivative 1 is 0 and derivative of y1 is y2. And this is 2y1 is equal to 1 plus y1 plus x into y2, which implies y1 minus कर देने से 2y1 minus y1 is y1 is equal to 1 plus x into y2. Again differentiating both sides with respect to x. Now we get derivative of y1 is y2, derivative 1 is 0. Here is the product formula, derivative x is 1 into y2 plus x into derivative y2 is y3, which implies y2 cancel हो गया, लेफ्ट साइड 0 हो गया, is equal to x into y3, which implies y3 is equal to 0, which implies if y3 means this is derivative of y2 is equal to 0. So derivative y2 is equal to 0. But we know derivative of constant is 0. So if derivative of y2 is 0, then y2 is constant. Then y2 is constant. Hope you all enjoy the successive differentiation class, and thanks.